another great section of this wonderful tutorial class. Today we are going to be looking at another wonderful topic, lovely topic, interesting topic in physics. Please ensure you don't distract yourself by any means. Ensure you are far, very far now from distraction in order to get the full details of everything you're going to be explaining here. Now, I know you are going to try. After this class, you are going to be teaching people this topic, as you are saying that you're just seeing here now. So, what you do for me now, you have to do this. You have to distance yourself away from what I call distractions. What I call what? Distraction. So don't distract yourself by any means. Alright, let's move to this topic now, which is dynamics. First we're looking at how the laws of motion under this dynamics. Now, what is not dynamics? Just as we have done kinematics, just as we have looked at what we call kinematics, we say kinematics is the study of motion, or it's a branch of mechanics which deals with the study of motion with no regard to the forces causing the motion. In the same way, dynamics now is a branch of mechanics that deals with the study of motion with regards to the forces causing the motion. Now, in this place now, we're going to talk about forces. Forces are going to show up here. A body is moving. The force that is causing the movement, we are going to be discussing it in this topic now. But in kinematics, we don't discuss the forces causing the motion. We don't discuss the velocity, the acceleration, the distance moved, the displacement. But in this place, we're going to look at the force causing the motion, look at the weight of the object, and others. So please ensure you follow me, so that at the end of the day, you'll be smiling. So let's look at the laws of motion now. Remember, dynamics is a branch of mechanics that deals with the study of motion with regard to the forces causing the motion. With regard to the what? Forces causing the motion. Now we have the laws of motion, or the Newton laws. The Newton laws of motion. These laws of motion, we don't have the equation of motion, so we have laws of motion, which is from Isaac Newton, the Newton laws of motion. And the first law of motion says that a body will continue to be in a state of rest or uniform motion unless an external force will act on that body. Unless an external force will do what? Will act on that body. The body will continue to be what? In a state of rest or uniform motion unless an external force will act on that body. So, if there is no external force, a body will continue to be in its state of rest, or it will continue to be in its uniform motion unless a force that is external will come and act on that body in order to oppose that motion or that state of rest. That is the first law of motion, and it's very true. It's very, very true. And this law corresponds to the inertia of the body. You're going to look at the inertia of the body. This is the tendency of the body to remain in its position unless something will come and change it. So this law, which is the first law of motion, corresponds to the inertia of the body. Now we have the Newton's second law of motion. We have the Newton's second law of motion. This says that the rate of change of momentum, is directly proportional. To what? To apply force. The rate of change of momentum. The rate of change of momentum is directly proportional to what? To apply force. Now, what is the meaning of momentum? And there's another thing that we call impulse. We call what? Impulse. Now, what's the meaning of momentum? What's the meaning of impulse? Now, from Newton, let's have a look at this. From that Newton's second law of motion, which is the rate of change of momentum directly proportional to the applied force, we can say that force, from that second law of motion, I cannot say force, which is total force on the body is equals to MA. This is from Newton's second law of motion. This means that the rate of change of momentum is directly proportional to what? Applied force. So constant velocity will be taken as what? 1 or unity. Now, what is the meaning of momentum? This is not momentum, this is mass, this is acceleration, this is force. Mass acceleration of the body will give you the force. on that body. Now, what is the meaning of momentum? What do you mean by momentum? I'm mentioning momentum. What is momentum? Now, momentum is the product of mass of the body times the velocity of that body. The moment of what? The product of mass of the body. Remember mass. What is of mass? Mass is the quantity of matter a body has. While mass times acceleration due to gravity give the weight of that body. Now, mass and weight are not the same thing. Mass is just the quantity of matter in the body. Mass is scalar, but weight is a vector quantity. Why? Because weight is the product of mass and acceleration due to gravity. And mass and weight and force, something like has the same, they are dimensionally the same thing, because they have the same unit. They have the same dimension. Take note of that. Take note of that. It's very, very important. So, mass times the velocity at which a body is moving will give us the momentum of that body. So, momentum, which is denoted by MO, momentum by MO, is equals to the mass of the body times the velocity of that body, which is mv. Why impulse is the product of force and time. Why is what? The product of force and time. That's impulse. Let's say force is acting on something. The product of that force and that time that our force is acting is what we call impulse. So impulse, I will denote by I, we denote impulse by I, is equals to force times what? Times time. So MO is momentum, F is force, M is mass, A is acceleration, F is force, then T is time. So force times time is impulse, mass times velocity is what? Momentum. Now let me show you something. Let me show you. Wait, listen. Let me show you. Now, impulse and momentum are dimensionally the same thing. Dimensionally, F times T is equals to mass times V. Take note of that. In dimension, in terms of dimension, F times T is M times V. You can go and prove it to check it. F, take what is the dimension of force, what is the dimension of time, what is the dimension of mass, what is the dimension of they express to check if they are not the same. They are dimensionally the same. So impulse and momentum are dimensionally the same. When something is moving with a force, we call it impulse. Let's say something is moving now and there's a force moving it. Let's say you tie to a car engine and there's a force moving that car engine and we call it an impulse. But when you now remove the force, there's no force again, and the body is still moving. With respect to the mass of that body, when something is moving without a force, but the thing is still moving, with respect to the mass of that body. So if you just want to get the impulse there now, we will call that impulse momentum. We will just know the mass of that body and the velocity at which that body is not moving. That's what we call momentum. The mass of the body times velocity. But when the movement is with a force, we call it impulse, which is the product of force and what? Time. So we can also define impulse. Look at it. I can also define impulse as change in momentum. Impulse can also be defined as change in momentum. Look at it. Let's look at something. We said, when we change momentum, initial moment, final momentum minus initial momentum. Change in momentum. So then we call momentum P. There's no problem. Change in momentum. Set it as the initial one, that's final momentum, let's say M2, minus the initial momentum, which is M1. So the final minus initial will give us the change momentum. Or I can say initial and final momentum we deal with, or we involve it, or we associate itself with final. Remember we have U and V. What is U? Initial velocity. What about V? Final velocity. So we can also put final velocity here. Mass will be the same, because mass will not change. Mass will not change. Mass will be the same here. Anyway, you get to something like, if you move this board now to abroad, the mass will still be the same thing. The mass will not change. So the mass will remain the same. Mass is constant. So we have the mass, which is M. Then the final, the velocity will change. Velocity can change. Now the change the velocity itself with time is equal acceleration. So we don't do it the final velocity minus the mass. What about initial velocity, which is also U? Then since the mass is the same thing, you can say M bracket V minus U. So this one is called change in momentum. And I'm telling you that this change in momentum is same thing as impulse. How? Look at it. From Newton's second law of motion, we said the rate of change of momentum. Rate means the rate of change of momentum means change in momentum divided by time. That's the rate of change of momentum. They say this thing is the same thing or is directly proportional to applied force. That means force is equals to, look at it, M. Force is equals to M times A. What is A? V minus U over T. Over T. This one is A. Change in velocity over time. So if you compare it to this, we are going to have F times T. F times T is equals to mv minus U. What is mv minus U? Change in momentum. Change in momentum. If you divide mv minus U, we call it on this change in momentum divided by time is called the rate of change of momentum. The rate of change of velocity is acceleration. The rate of change of momentum is equal to force. Look at it. Rate of change of momentum is equal to force. Change momentum over time is the rate of change of momentum and it's equal to force. And look at it. If you multiply this thing to this place, we will have F times T is equal to v minus U. What is v minus U? Change in momentum. And this change in momentum now is equal to what? Impulse. So you can also say change in impulse is defined as the change in momentum of a body. You are still correct. Impulse is what? Defined as the change in momentum of a body or the product of force and what? And time. So dimensionally, impulse and momentum are what? Are the same. Please take note of all these what do you call it? All these formulas. We're going to be using them. Very, very important. Now we are still going. We're still going. Don't worry. We are still going somewhere. We are going somewhere. Now let's look at something. Let's look at something. Third law of motion. Newton's third law of motion. This law says that for every action, the Newton's third law of motion says that for every action, there must be equal and opposite reaction. For every action, there must be equal what? Opposite what? Reaction. Action and reaction are equal and opposite. Action and reaction are equal and what? And opposite. Take note down. Action and reaction are equal and what? Opposite. Now let's look at the law of conservation of linear momentum. The principle of conservation of linear momentum. So let's look at that. Let's go take a look at that. The principle of conservation of linear momentum. When the body is moving linearly, the momentum of that body, linear momentum. The principle of conservation of linear momentum. Remember what is momentum? Product of mass and what? Velocity. Don't forget that. Don't forget that. So let's have this. The principle of conservation of linear momentum. The principle of conservation of momentum. The conservation of momentum. Or linear momentum. Now, this principle states that if two bodies collides, if two bodies what? Collides. If two bodies collides, the total momentum before collision must be equal to the total momentum after collision. The total momentum before collision and that of after collision will be the same. If there is no external force acting on these colliding bodies, if there's any external force that is acting, no external force is acting, the principle is telling us that if two bodies collide with each other, when of colliding means if they jam. That's what we use in pidgin English. People jam each other. We can hit each other, hit each other. The total momentum before it or before they collide with each other will be the same with that of after they are collided with each other. So let's say we have body A. Let's say we have body 1, or let's say body A. We also have body B. This one is moving this direction, moving this direction. The moment of this one is the mass times the velocity. That will be the momentum. What about this one? The mass times the velocity. The mass times the velocity is momentum. Remember we did that before? You know I'm using U for initial, before they collided. That is the initial momentum. Then, if they not collide with each other, they face each other or not, so they not collide with each other now, maybe they will be moving together let's say they're moving together in the same direction, and both of them moving together in the same direction. Then we're going to have the mass will still be the same. The mass will still be the same, A, V. The velocity may be different. You have VA, VV, or the velocity may be the same thing at the end of the day. The velocity may be different, or the velocity will be the same, as the case may be. So the total momentum here is the mass A and the velocity at A plus mass B and the velocity at B must be equal to the final momentum mass A times the velocity that which is the final velocity at B at A plus mass B times the final velocity at what? At B. That will be the final momentum. That will be what? The final momentum. So this is the initial momentum, the final momentum. So the momentum before collision will be equal to what? The momentum after collision. So this is the momentum after collision, this is the momentum before collision. But if the after collision they move in the same velocity, they move with common velocity, VA will be the same thing as VB. You can just call them V. So put V here. That V will be equal to, for example, I want to write this out, I'm going to write it this way. So I have MA UA plus MB UB is equal to MA V plus MB V. If you factor out V, if you factor out V from both sides, since V is the same, if you factor out V, you are going to have something like this. You have something like that. Then if you make that V, so the formula V will be equal to MA UA plus MB UB over MA plus MB. This one we're going to have a common velocity. Now, collision can either be elastic or inelastic. So I would like you to go and look at that one. How can a collision be elastic? How can a collision be inelastic? Remember, in kinetic theory of gases, they said collision between gaseous molecules are perfectly elastic. Now, what do you mean by when something is perfectly elastic or when something is elastic? Now, there are some collisions in which after collision, only momentum will not change, or only momentum will be the same thing. Then the kinetic energy will change. There are some collisions in which after collision, the kinetic energy will not change, the momentum will not change. Situation like that. So we have elastic collision, we have inelastic collision. For elastic collision, after collision, both momentum and kinetic energy are conserved. For inelastic collision, only momentum will be conserved, but kinetic energy will not be conserved. So you can pop your nose into those types of collision, which is elastic and inelastic collision, and look at it very well. Before I go into questions now, I'm asking questions. Let's solve some examples. Let me look at the quantities, work, energy, and power. I just mentioned kinetic energy. So let's look at work, energy, and power. Let's look at work, energy, and power. Now, what's the meaning of work? I'm going to summarize it in a very something like briefly. So, what's the meaning of work? Work is the product of what? Force and distance moved in the direction of the force. Work is the what? The product of force and distance moved in the direction of the force. Work, W, is equals to force times distance moved in the direction of the force. Now, we can take this distance moved in a direction known. If the direction is known, we call it displacement. If we now call it displacement, force will become vector. That distance will become displacement. We are now multiplying two vectors to get a work which is scalar. We now call it dot product. You can also say work is equal to force dot D. Where D is displacement. Also use this dot product to look for work. I did that when I was doing the dot product. Look at dot product of vector. You also see something like that. So let's get something new. Another thing very important. Another switch something. Now let's we have a block here. Then we want to move this block to this place. And I'm something like taking the force at an angle which is making angle theta to the horizontal. So which work will be done when you move this body from here to here, which is distance D. The work done will be you resolve this force to the horizontal, because work is the product of force and distance that is moved only in the direction of the force. So the distance should be the direction. The direction is in this side horizontally. The body is moving horizontally. So the horizontal a component of this force that will be F cos theta. So we put times D there, which is also the distance. So F cos theta will be another component times the displacement, which is D. So FD cos theta, that will be the work done there. So let's quickly look at energy. Energy is the ability to do work. Work and energy are dimensionally the same. Take note of that. Unit of work is Newton meters or joules. Unit of energy is also joules. We have energy like mechanical energy, we have heat energy, and so on. Now, mechanical energy can be in two forms, like we can have the potential energy, we also have the kinetic energy. But know that energy is the ability to do work. Energy is the ability to do work. So the two forms of kinetic energy can either be kinetic or potential. We also have kinetic energy or potential energy. What is the meaning of kinetic energy? Kinetic energy is energy possessed by body by virtue of its motion. By virtue of what? Its motion. And it is defined as Ke. It is defined as Ke, mathematically Ke is equal to half mv squared. Energy, body, motion, by virtue of motion. Then potential energy is the energy possessed by virtue of the state of rest of a body. The energy possessed by a body that is something like energy stored. That is energy that is not that is possessed by a body by virtue of its state of rest when you are resting. We also call it energy stored in the body. That is potential energy, and it's mathematically defined as PE. PE, which is potential energy, is equal to mgh. So I'm going to quickly. Now, we also have something. What is the meaning of D? Okay, this one already answered. What is the meaning of mass, velocity, addition to gravity, G. G in this class now, we can either be using G as 10 meters per second, so it's a constant somewhere, or we use G as 9.81 meters per second square. Whether I'll be using G as this or this, depending on the question, or you give you a question and then to calculate in which you be requiring G. So let's look at this. And there's another thing also look at here. Very important, something that is very sweet, which is power. What is your power? Power is the rate at which work is done. Power is what? The rate at which work is done. Or work done divided by time. Look at it. Energy divided by time is still power. Because energy and work are dimensionally the same thing. So dimensionally, you divide this number by time, it will still give you power. So power, which is P, I remember P will be equal to work done over what? Over time. Take it. Or power can also be the force on the body times the velocity of that body. Force times velocity is power. So take note of that. Power is the force times what? Velocity. A car engine. Let's look at this question. A car engine uses a force of 500 newtons. Uses a force of 500 newtons. Uses a force of 500 newtons to maintain a velocity of 100 meters per second. To maintain a velocity of 100 meters per second. What is the power developed by this engine? What is the power developed by this engine? Solution. We said power is what? Power is force times what? Velocity. Which is 500 times 1000. That will give us 50,000 watts. That is power developed by that engine. That is the power of the engine. 50,000 watts. Or 50 kilowatts. Now to convert this one to kilowatts, just divide it by 1000. It will move to kilowatts. So it's as simple as that. Very, very simple. A body of force. A body uses a force of 10 newtons. When you use a force of 10 newtons, the body uses a force of 10 newtons to maintain a particular distance, to maintain a particular distance for 5 seconds. To maintain a particular distance for 5 seconds. What is the impulse developed by this body? What is the impulse developed by this body? The body uses a force of energy to maintain a particular distance for 5 seconds. What is the impulse developed by this body? Impulse I is what? Force times what? Time. That is equal to 10 times 5 times 50 Newton seconds. 50 Newton what? Newton seconds. As simple as that. As simple as that. See, all these things are not that hard. Don't think they are very, very hard. See, these things are very, very hard. Not very, very hard. It's not that hard. So look at this question. Another sweet question. Another sweet question. Another very sweet question. This is one. So let's have the next one now. Another sweet question. A body of mass 5 kg. A body of mass 5 kg. A body of mass 5 kg. Moving with a velocity of 10 meters per second. A body of mass 5 kg. Moving with a velocity of 10 meters per second. Moving what? A velocity of 10 meters per second. Collide with a stationary body of mass 15 kg. Collide with a stationary body of mass 15 kg. Collide with a stationary body of mass 15 kg. Calculate their common velocity after collision. Calculate their common velocity after collision. Calculate their common velocity after collision if they move in the same direction. Calculate their common velocity after collision if they move in the what? The same direction. So let's look at this question solution. What will be the solution to this question now? They said the mass of this body, the body of mass, particular mass, can I call this one? Our first one is M1 or MA, 5 kg. And moves the velocity of what? 10 meters per second. Then another one of mass, 15 kg. What velocity is using? 0, because it is not moving. It is stationary. It's at rest. It's just resting. Stationary. Where it is. Let's say you are standing where you are now. Somebody will just want to come and hit you. The people will not fall to the same direction. Which velocity people fall or move in the same direction. So we know that common velocity of a body is M1 U1 plus M2 U2. All over what? M1 plus what? M2. Remember, we're using MA UA plus MB UB over MA plus MB. It's not the labeling. I'm just using 1 and 2 now, not A and B. Ignore that. So this one will be 5 times 10 plus 15 times 0 over 5 plus 15. So 5 times 10 is 50 over 20. Cancel this. That will give us 2.5 meters per second. That will be the common velocity in which two bodies move, 2.5 meters per second. Take note of that. It's very, 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 very important. Now let's look at this other question. Another question. A body of mass 15 kg. A body of mass 50 kg. Body of mass 50 kg. Initially at rest 5 meters above the ground. Initially at rest 5 meters above the ground. Force and penetrate 15 cm into the earth. 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 Calculate the loss in potential energy of this body. Calculate the loss in potential energy of this body. Calculate the loss in potential energy of this body and the average or the resistance of the earth. And the resistance or the average resistance of the earth. what will be the potential energy of this body? Loss of potential energy since it's falling from rest. What will be the loss of potential energy of this body? And the resistance of this earth, if you penetrate, we're able to penetrate how many meters? We're able to penetrate 15 cm. And you know that 15 cm, that's the penetration. Let's call it Pn penetration. And the penetration is what? Penetration is 50, that is 15 over 100 divided to meter, that is 0.15 meters. 0.15 meters, this is the height of the body, and this is the mass of the body. Now, in this question, take G as 10 meters per second square. Take G as 10 meters per second square. So say PE is 10 GH. So the mass of the body is 15, and the acceleration to the body is 10. Then the height in which the body is falling from is 5 meters. So, if you have this, you will have 750 joules. That's what we will be having. So, what will be the resistance? The second one. What will be the resistance of this earth? If this body that has this potential energy penetrates, we're able to penetrate 0.15 meters. So, resistance is just like the force. The earth is going to cause action and reaction. What will be the reaction of the earth? Of how much resistance will it have? How much force will you give in the reaction? Do the same thing as force. So the resistance will be calculated as the potential energy divided by the penetration of the body. Potential energy was 750 and the penetration is 0.15. That will give us 5,000 newtons. That will be the resistance of the earth. 5,000 newtons. So please take note of that. It's very, very important. So let's look at this other question. Next question. Calculate the change in momentum of the body. 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 And use a force of. And use a force of 50 newtons. And use a force of 50 newtons in 2 seconds. And use a force of 50 newtons in 2 seconds. What will be the change momentum of that body? So, solution. If I tell you, change the momentum, change as what? Impulse. That is 50 times 2. That will give us what? 100 Newton seconds. That will be the change in momentum. Change in momentum, change as F times time, which is impulse. So, another question. It's very simple. You understand what you are doing. Things. I told you, after this class, you will be happy. Because you have known a lot of things today now. Let's try this other question. Another lovely question. A force reduces a body of 5 kg. A force reduces a body of 5 kg from 7 meters per second to 3 meters per second. From 7 meters per second to 3 meters per second. As a force reduces a 5 kg body moving 7 meters per second to 3 meters per second. That is a reducing force, a negative force. In 5 seconds. In 5 seconds. In 5 seconds. In 5 seconds. Calculate the force. In 5 seconds. Calculate the force. What will be the value of this force we are talking about? So, solution. Remember, force is what? MA, which is M times V minus U over what? Over T. So this force will be M is 5 times V, T minus 7 over 5. And we will try to cancel 5. 3 minus 7 was minus 4 newtons. That is the magnitude of this force. The way is negative force. That means that shows it's reducing the speed. It's not increasing the speed. So the magnitude of the force will be 4 newtons. That is the force. The force is 4 newtons. But It's a reducing force. It's something like you're reducing the velocity. So it's a negative force. It's a negative force. So, and so on. You keep on solving questions in this place, and we will not stop. We will not stop. We will not stop. So, I would like to calculate this next one. Let's calculate this next question. Let's calculate this next question to see how far we have gone. Calculate the change in velocity of the body. Calculate the change in velocity of the body of mass 10 kg. Calculate the change in velocity of the body of mass 10 kg, which receives a force of 70 newtons. Receives a force of 70 newtons for 20 seconds. What will be the change in velocity of that body? What will be the change in velocity of our body? What will be the change in velocity of that body? What do you change in velocity? Change in velocity means final velocity minus initial velocity. That means change in velocity. That's the meaning. So remember that m times t is equals to m times change in velocity, which is v minus u. Or let's say m times change in velocity. Do that. So the value goes out by m now. Let's say by m. We cancel this. Our change in velocity will be equal to m times t y, which is 70 times 20 over 10. So cancel this. That will be 140 meters per second. Now we change velocity of that body. 140 meters per second. 140 meters per second. So I can also ask you, what will be the change momentum of this body? Change momentum will be the mass times change velocity, which is 10 times this, which is okay. What? Okay, another question, more question on this one now. Calculate also the change in momentum of this body. Calculate also the change in momentum of this body. So the change in momentum will either be change in momentum will either be the force times the what is it called? The time, or the mass and change in velocity. The change in momentum will be mass, which is 10 times is equal to 10 times v minus u, or m times change in v, change in velocity. That will be 10 times 140, which is 1,400 milliseconds. That will be the change in momentum. Calculate the work done. Last question. Because you can solve questions upon questions. So after this class, you just go and look for questions under this laws of motion, dynamics, and solve as many you can solve. Calculate. Let's look at this. Calculate the work done of a body. Calculate the work done when a force of 500 newtons. Calculate the work done when a force of 500 newtons move a distance of 10 cm. When a force of 500 newtons moves a distance of what? 10 cm. You say work is what? Force times what? Distance. And this one is set as 10 over 100, 0.1 meters. So that will be equal to 500 times 0.1, that is 50 joules. That is the work done. 50 joules. That is 50 joules. So we have so many questions. Like calculate the kinetic energy of the body. Calculate the kinetic energy of the body. Calculate the kinetic energy of the body of mass 20 kg. Calculate the kinetic energy of the body of mass 20 kg. Moving with velocity of 2 meters per second. Moving with velocity of 2 meters per second. So what will be this kinetic? What will be the kinetic energy? The kinetic energy will be 40 joules. That will be kinetic energy. What to use. So you try this one now. Try and solve this last question on your own. This is the mass of the body. This is the velocity of the body. What will be the kinetic energy of that body? So you can also look for other questions under this topic. Look for more questions and solve. I've done a lot in this class. And if you don't have any question bothering you, just look at the class again, watch over and over again. And if you still have other questions, you are free to drop it in our comment section. So thank you, God bless you. We'll see you guys in our next class. I love you. Thank you.